First and foremost, thank you everyone for joining us. I'm actually kind of glad we're all virtual if you're in the DFW area, so everyone's safe and off the roads with all the ice and crazy weather we've had today. So hopefully everyone's good there for the local DFW folks, and thank you to Jim and Google and the rest of the Sabre team for inviting our team to present today. We've been looking forward to this, but for kind of the agenda and what we have planned, we're going to go through some quick intros. I'm lucky to have a great team that's going to be walking you through, so you don't have to hear from the sales guy today. But we want to make this a great learning environment, who Aviatrix is, talk more about secure cloud networking, kind of how you're embedding security into your cloud environment today, the value and the business overview of what we can provide. And then we'll even do a little demo of what we call Copilot. And then from there, we can do more of a technical deep dive and an open Q&A. So that's what we've got planned. Rod's going to kick it off for us. He's our VP of marketing. And Rod, over to you, ma'am.
All right, great. Yeah, so I'm going to do my part getting you to the demo in about 10 minutes. So this is just a quick introduction about what Aviatrix is. And I like to introduce Aviatrix through our customers. So this gives you an idea of the kind of customers that we're working with. And you can see that, we have probably approaching 600 enterprise customers today. You can see on this slide a selection of those from every different vertical out there, 64 of the global Fortune 500. So we're dealing with very large enterprise accounts that are moving to the cloud. And I'd say about 60% of these are in a single cloud, but all of them know that a multi-cloud environment is coming down their way. So they're trying to architect their cloud environments in a way that they can support multi-cloud. Well, one of the things I'd like to mention is Gartner is actually recommending Aviatrix. You can see here in a quote that they had that organizations that are looking for advanced network functionality that's missing from the native cloud providers should shortlist Aviatrix. And so if you're working with Gartner, reach out to them. They're very familiar with us.
Hey, Rod, sorry to interrupt. I can only see your title slide.
Okay.
I don't know if that's the case for everyone else. There we go. Now we can see.
But shouldn't I be able to? Do you see it move?
No.
Okay.
You're
so I
not.
guess I'm just going to have to play them this way.
I don't know.
You can see them now, right?
Yes.
All right.
And it's
okay.
not in presenter mode, by the way.
Yeah, it's not in. If I go into presenter mode, you don't see it.
Got it. Perfect.
Yeah. Okay, so as you all know, the way that you build networking in any one of the clouds is different because of the underlying constructs are different. So what we do is we actually programmatically leverage and control the native constructs. For instance, in a Google Cloud, we would manage the route tables that are associated with a VPC in a very native way. But at the same time, we add advanced networking and security on top of each one of these clouds so that you end up being consistent across all your clouds. So now the way you build the network in AWS is the same in Azure, is the same in Google or Oracle, and we work with Alibaba as well. But this gives you a consistent way to actually build the networking constructs. Then that gives you consistent visibility and troubleshooting. And this is one of the things that we'll be doing a demo with, so I won't spend a lot of time talking about each one of the things that we do there, but Mark will show you a demo of our network operations, security operations center called Copilot here as soon as I'm finished with this section. And then we give you consistent security. So going across clouds, being able to do multi-cloud network segmentation or have the same kind of policies that go across the clouds. And one of the things you'll see as I finish the presentation here is we're embedding a lot of security actually into the network constructs that we're delivering. So now the core network, the data plane actually becomes the place that you can do a lot of security as opposed to just connecting it into that core network. So for instance, we support Palo Alto networks firewalls connecting into the network. But as a complement to that, I'll talk about some other things we do in consistent security. And then consistent automation, right? So we have a single Terraform provider. You can write one infrastructure as code module, and it works across all of your clouds. Now, you'll hear multi-cloud from a lot of different vendors, but beware of that, because most people who talk about multi-cloud are talking about connecting to multiple clouds, not actually doing multi-cloud networking. So they actually stop at the edge of the cloud and then hand you off to the native constructs, which again are different in each. And so you end up with the same problem that you had before. So let's talk a little bit about the embedded security that I mentioned. So with our data plane, we're seeing all of the traffic that goes across this multi-cloud data plane. And we just released a feature at the end of last year called Threat IQ with Threat Guard. And what we do here is we see every header, so every source and destination address, and then we compare that to a threat database of malicious IPs. Now, we don't come up with this threat database. It's from Proofpoint, which is the same company that AWS uses for guard duty and so forth. But we can see, for instance, that something in a particular VNet is talking to a malicious IP and highlight that. So we identify the threats there. And this is a screenshot. I took a little bit of Mark's thunder here, only one screenshot. But this is Threat IQ, and this is from a customer screenshot of all the different threats, known threatening IPs that they were talking to and didn't even know it. Even though they were spending a lot of money on security products, they were all single point of inspection products. So if the traffic wasn't flowing through that single point of inspection, they didn't see it. And then the other nice thing that we can do is, now that we see it, we can actually shut it down, because we control that data plane. We can put a blocking rule right in there and shut down that communication to the threatening IP, not to the entire VPC or VNet, but just the communication that was talking to that threatening IP. And then we just released a product that's going to be shipping at the end of this month called Network Behavior Analysis. And this is how we're going to be able to look for things that aren't known threats. But for instance, look at a normal behavior and see anomalies that go outside of that normal behavior and highlight those. So let's say, for instance, it might be something talking to a new ports or new protocols that wouldn't typically have been part of this application environment, and then highlight those. Of course, we won't just shut those down. We'll just notify you on those. And then there's a bunch of business values that, if you're interested in this, we can go through in details. But these are some of the things that we've heard from our customers. And a big one is driving higher revenue and margins from existing customers and accelerating acquisition integrations. We hear a lot about resource efficiency. What used to take 6 people now only takes 1. There's a lot of bridging of the skills gap, where you might have somebody who's an expert in Google Cloud, but maybe now you got to move into Azure Cloud and you don't have experts there. And then reducing business risk with some of the security things I already talked about, but there's a whole list of other security things that we do. So with that, I want to turn it over to Mark. Mark, you can take it away for a demo. I'm going to stop sharing, and then you'll need to start sharing, I believe.
Okay, great. Thanks, Rod. Thanks for the introduction. Please let me know if anybody is having any trouble hearing from me or seeing from me. Hopefully I'm selecting the right one. All right, this is good.
We can hear you, can't see your screen yet. Oh, now I think we're seeing your screen.
Okay.
With me kind of funny face.
Yeah, nice little infinity loop there. Yeah, so yeah, all right, anyway, and thanks again for the introduction, Rod. Hopefully, yeah, you didn't steal too much of my thunder. My name is Mark Cunningham, and I'm a sales engineer for Aviatrix. I do work with Matt and Rod regularly, so they invited me to come and give you guys a demo of Copilot. And what I wanted to touch on is, I hope everybody can remember and think back a few minutes ago to the slide that Rod was showing, where you saw, you see a lot of these little red spheres that, outlay the architecture, and it seems to kind of line up in this repeatable pattern. And that's generally the, the architectural motif that we extend from. And so when I go and I try to put something up on the screen, where I'm going to show you Copilot, and I drop right into the topology screen, I'd like to draw attention to that hub and spoke design. And you'll see a repeating pattern of like the blue spheres surrounded by, several different pairs. And that's essentially the same exact construct that you were seeing in that. And this rolls out into, I've got an AWS transit core with a pair of spoke gateways here, a pair of spoke gateways there. And the blue spheres, these also represent a pair of gateways, but these are the actual transit cores. Now I can open these up and I can open the cluster, but it tends to get very busy on the screen. But I just want to make sure that everybody is aware of just what those are, so that it becomes clear throughout the, as I go through this. So going back to the dashboard, to give you a summary ideation of what Copilot is, Copilot is the extrapolation of all of the network intelligence, data and analytics that we are able to give you in terms of data visualizations and our own NetFlow collector. And it's a very powerful summation of all the power that we've been able to bring together under one roof of a multi-cloud networking platform. And what you'll see here, it starts with our gateways, and the different metrics of what is currently in use and what is currently part of your architecture. It also is giving you, some stern warnings about, connections that are down, BGP sessions that have been lost, current number of VPN users, as well as, the total threats that have been detected over the past 24 hours. So you come right out of the gate in the dashboard with a lot of really useful information. And the point of Copilot is I like to put myself in the seat of, the network technician that has just been handed a ticket and is now trying to track down the source of a problem, and what that is actually like for him or her as we spend a day in their shoes. So there are submenu options that you can see over here at the top. If I click over here, this is going to take me to a traffic analysis screen that is going to give me some metrics about what's been actually going on in my cloud network over the past 24 hours. I can see these things constrained at the level of the region. I can also see them at the level of the VPC and the VNet. I can look at these analytics from the perspective of the gateway, and as well as the instances themselves that make up the bulk of my Aviatrix data plane. So again, we have all this data because we're giving you a really good bird's eye view of your multi-cloud network, regardless of what cloud it's in, because as we build this VM-driven IPsec tunnel-borne fabric that's known as the Aviatrix data plane, these embed within the native cloud constructs, and we write to those underlying constructs and integrate with all of the native routing in a way that you don't have to go to town and learn each of these different clouds independently. You can now do it with a singular motion, and the architectures that you'll build in one cloud can be repeated in each of the other clouds. So it's really important to kind of, get a good understanding of where those VMs run, and the power that they're going to bring to you for running your multi-cloud network. Now, here in the topology view, there's lots of really good information that you can find just from the topology view alone, and any kind of forensic investigation or network troubleshooting ticket that I'm going to work with. It's always going to start right here. Now, this is a real-time heads-up display of the current state of your network architecture, as well as a visual depiction of all of the networking that you've implemented to date. I have a really good understanding of the cloud constructs as they are, by cloud. So this is my AWS section right here. This is my GCP right here. Down here is my Azure. And then over here, I've got Oracle. And this is a responsive design. So anything that actually changes the networking conditions, if I build something, if I tear something down, if the latency suddenly increases from AWS North Virginia over to US East Microsoft, these networking conditions are going to be made aware to me as I'm able to interact with all those metrics right away. And just to show you a little bit about how responsive the design is, say in my quest to build a full mesh network, I've yet to actually connect the OCI cluster. Oh, is anybody home? I've yet to actually connect the OCI cluster to my Google Transit. So I can just head right back on over here to the controller, go to multi-cloud transit, head to the transit peering section, create add new, select GCP, go to OCI, and those are the connections we're making, GCP to OCI, and then I can just hit OK. Now, normally, what would be involved of actually, going through and actually what is actually going on under the hood here, it would be, maybe up to an hour of creating, a VPN gateway in OCI or standing up some kind of instance in Google, and then trying to build some kind of IPsec tunnel to a certain extent, and then trying to get routing to go through them, as well as to actually apply some kind of security policy, based upon what the business is going to demand. All of those functions, all of those considerations, all of that technical debt that one would incur for that function itself is actually all accomplished with just a couple of clicks. Now I just went ahead and refreshed the screen, and you'll see that I now have a tunnel built between OCI and GCP. And based upon the routing policies that I have at the level of each of these networks, I'm going to be showing routes. I'm also going to be showing more paths for me to get from one place to another based upon the routes and the metrics that are now available because of this peering. If I zoom in here, you'll notice that there's no latency metrics just yet. That actually takes about a minute or two for that to build up. And Rod, if I do start getting questions, coming into the queue, can you rattle them off for me as I go from one section to the next?
Yeah, will do. Okay,
great. So it's really important to when you're getting a feel for Copilot, you're going to work a lot with the topology section here. There's different ways to visualize this data with our transit and our MCNA views. I won't go into detail on that, just for right now, but the things that you can do right here is you can actually begin troubleshooting connectivity for, say, you have some kind of ticket that you need to work with. So let's say I have an application here called AppIQ in AWS. Now, everybody in AWS who tunnels in through the VPN concentrator or comes in through the direct connect that's connected to your office, they can all get to the app, no problem. They can get HTML, they can make commits to the database, everything's working great. Now, everybody coming in from the Azure section, anybody coming in through a Windows virtual desktop or coming in through the express route and then riding over the transit, they can't get to the application. This page cannot be displayed. Error 503, server timeout. Pick your problem. What you can actually do here is you can begin troubleshooting that network outage, or let's even find out if it is a network problem, right here from within the topology map view. Because I have access to all the metadata, one click of the computer icon on the screen, and I now have the private IP in my clipboard. Then I can go down here to the offending gateway where the user is connecting from, give it a click right here, and then I can begin running diagnostics right from in the screen. So I'll go over here and I'll hit a destination, type it in there. We'll use the route table. Well, you can use Ethernet 0. Then I'll go ahead and start throwing pings at it. Now, this ping, based upon the way I think I have this configured, I think this ping is going to fail. But let's actually try to continue the story as if it didn't fail. So if it didn't fail, what does that mean? That means I've got a route from one place to the other. And I also have a stateful firewall rule in terms of an NSG or a security group that's allowing ping to go back and forth from that. So if I've got that much already, but still I'm having an inability to connect to the application server, maybe there's more than needs CI to what is actually going on here. So I've got a whole slog of tools I can then begin to leverage, from right here within this view. Single pane of glass is our motto. I can go to trace route, trace path. I can test the connectivity at layer 3 and layer 4. I can see all the active sessions that are actually running through these gateways. So it's a very, very powerful component to own the data plane because you do have quick access to these kinds of details. Now, if I want to zero in a little bit further and find that actual packet, let's code 1071.0.4. Okay, and then this is the flow that I'm actually looking for, that second one right there. Now what you'll see is the source and destination IP, the source and destination port are an exact mirror of itself on the other side of the actual record right here. So what that tells me is that now I'm not dealing with an asymmetric routing problem. So I have further narrowed the scope of what I'm actually going to be looking into. So I can pull interface statistics from my gateways. I can even go so far as to do a packet capture. And I can do a packet capture from both sides of the actual flow. And I can do that because I have total control over the data plane. And I'm able to pull all this wonderfully enriched data, from my network virtual appliances there in the form of the gateways. Now, I'm not actually going to take a packet capture right here, but what eventually you start being able to work with is like maybe I'm going to do a packet capture and I'll see that the windowing was coming back as a 0, like every 1.5, every 2 seconds. And if you see a windowing at 0 at that interval, that's a really good indication that your application server is out of memory. And so what this actually boils down to is that being able to have Aviatrix as something that you can leverage, as well as be able to provide access to maybe different application teams and application owners, you can actually start spinning up a small amount of expertise within those different teams so that they can begin triaging and troubleshooting their own application server environments to the point of, when you don't have an actual, definition of, is this a network problem or is this an application problem? Okay, so we did kind of start a little bit late, so I'm going to be running behind here. I can go over a few more things before I've got to jump. One of the other really powerful functions is our topology replay. Go ahead.
Okay. Let's make sure you hit flow IQ and app IQ, thread IQ.
Thread IQ, yeah.
Okay, great. So one of the things that we're going to be taking a look at here is topology replay. Topology replay, I think, is one of the more fun things that you can actually use. A lot of times, my network support team and my support staff, they'll let me know that customers will call in and they'll say, hey, I got fuzz, can you do something? Application's down, network's down, I can't reach the internet. What do I do? Can you help me? And my support team will say, absolutely, sure, let's get down to business. And they'll say, so what'd you do? And what does the customer say? We didn't do nothing. And my support team says, oh, okay, nothing. All right, I love that problem. Let's go into topology replay and let's take a look at all this nothing that you did. So as you can see down here, I've got 6 changes actually in the record right now. And this is actually the change I just made with adding that route from Google over to OCI. And you can see that Right here, you see that the BGP advertised route went from 8 to 10. And down here, it went from best routes via transit period, went from 6 to 8. So not only are you seeing the APIs expressed, but you're also getting kind of a receipt from what happened afterwards, kind of like a response, but we also give it to you within the context of all the neighboring properties that were affected as a result of that change. Now I can go down here to any point in time. Let's say I want to look at this change right here that happened on February 15th at 7:26. I want to see what somebody did over here. All right, looks like they built something in this account. They went over here. Okay, well, that data is not very interesting to me because it looks like nothing broke. So I can keep going down the line, and I've got a complete record of all these changes that were made. I can strain it through the view of the topology, and so I'm going to have a really good understanding of everything that actually went wrong, as well as I have the ability to audit this. And really, what it boils down to is that anytime something within the cloud changes, I'm going to have the ability to find out what changed, who changed it, when it changed, and what was used to change it. So a lot of really powerful features are built into Copilot that don't just accent the network admin's ability to operate and manage the cloud, but it's also going to extend into other areas like billing and audit, especially as we get into more of the advanced security features and things like that. Flow IQ, this is your forensic investigation tool set right here. You have the ability to query the NetFlow records and apply filters to them over any stretch of time that you designate. Let's say I want to take a look at all the NetFlow records over the last week, and I want to see everything that came from a particular IP. I'm going to go ahead and give this blue sphere a click right there, but I can build in these filters manually, or if I see the actual component that I want to bring in, I can actually just go ahead and use the graphic user interface. I can add more rules here. I'll say the destination address is equal to 10.31.0.119. I think that'll work just fine, so I'll throw that in as well. And I also have the ability to keep applying filters, as well as filters within the context of Boolean logic. So show me everything from here to here, but not this and not that. So it's a really powerful query tool set that you can use to work with all the different NetFlow record possibilities.
Can you show the geolocation really quick? Just kind of like a week
Sure,
long.
absolutely. Notice I went from overview past trends on the geolocation, and the actual query and the filters that I applied there, followed with it. I want to see a little bit more data, so I'm going to remove these filters. Go ahead and clear all. Now, what you actually get here is you get a really good heat map of that's going to give you indicators of what is actually going on within your network and where is the data starting and going from. I can maybe I should take a look right here. I don't have any business in South America. Over here down in Sao Paulo, I noticed there's a lot of data going here. Well, 5 kilobytes is not an extraordinary amount of data, so it's probably just a ping reply to the AWS local zone. But if you see large amounts of data going to a place that you don't have familiarity with to another place you don't have familiarity with, it might be a good indicator for you to do a little bit more digging. You can also copy these filters and look at them in terms of flows. Like a lot of what you get from the heat map, but you actually will see the start and the finish origin. And then you can query the NetFlow records directly from the records map. So I can go in here and I can modify the columns, and I want to add a lot of these geo destination autonomous system numbers, locally masked length destination port, and then I can also constrain the data with some filters as well. Moving on to App IQ. Now, App IQ is actually one of our more favorite parts of the application. I call this the Friday night returning tool, because what it does allow you to do, it does allow you to query the availability of connectivity between any point in your cloud to any other point in any other cloud or on-prem, with respect to the port protocol and whether or not it's going to be over a private or public interface. So I'll go ahead and leave this as private, all protocols on port 443, and I'll go ahead and hit submit. Now what this will do is this is going to come back with a report that is going to give me a lot of detail about the route tables, the TGW configurations, the peerings, the network security groups, the regular security groups, the network access control list, anything that either was configured appropriately to give me access across those 2 points, or anything that actually stood in my way. You get a lot of Aviatrix performance monitoring data and the latencies, between these 2 points. And you also get this flow data right here. But as soon as you come down to the bottom of the report, what you'll see is that the network ACL passed, the route table passed, the security group passed, the Aviatrix spoke gateway route passed, the Aviatrix transit gateway route passed. I think this is going to continue to show me that things passed. So what this means is that now you have an ability to you have an ability to see connectivity all the way across here. Hey Alex, I'll be right there.
Aaron asked a question on whether it has. Can you flip it over?
Say again.
Aaron asked if we have dark mode. Can you flip it to dark mode? We
do have dark mode. It is everybody's favorite. All right. So last but not least, I do like to get a little bit into the weeds with threat IQ. Personally, I came from a security background, so I grew up as a penetration tester and PCI auditor. So a lot of this stuff, the importance here really does, weigh true. What our network does is it allows you to detect malware or the presence of bad actors on your network in real time, and actually be able to intercept any kind of weaponization of their payloads into your network in real time and prevent infection. So this is something that in case somebody in your organization clicked on an email, or a developer, on one of your teams actually used a bad package that was preloaded with, some ne'er-do-well code. This is the tool set that's just going to keep those problems from ramping up on you. Because we can detect threats in real time, we'll see that something is actually going to make a request outbound to go to, either a Tor node, an otherwise known bad IP, based upon the reputation and threat assessment scores that we pull in from our cloud service. And as it is analyzed according to the traffic that you send over your Aviatrix data plane. Now, not only can we see this traffic actually, trying to go outbound in real time, but we also give you a mechanism to actually block that traffic. Now, in terms of automatic, network healing or otherwise mitigating threats in real time, this is about the best thing you're going to get, because you can actually have a firewall rule, get thrown up, at the source. That's gonna block it at the level of the gateway, at the resolution of a /32 source and destination, port protocol as it is appropriate. So you're not going to see this interfere with the rest of your production traffic. All right. Do we have any questions on that?
I think we got it covered, Mark. I think if you've got to run, I know you've got another meeting you're supposed to be. It's a good, quick overview of what Copilot looks like. So really appreciate you jumping on for that.
All right. Thanks, guys. You guys have a great day.
Thanks, Mark.
And then, see, I think we're going to jump to Matthew.
Yeah, that's me. Hi, just trying to figure out which screen I want to actually share. I think this is the right one. All right, so yeah, that looks correct. Yeah, hi everybody. I'm Matt Kazmar. I'm a senior solutions architect at Aviatrix. I tend to focus primarily on GCP these days, but as a couple people in the audience know, I used to be a big Azure guy, worked at Microsoft for a few years, so I'm fairly well-rounded, I like to think anyway. In contrast to Mark's presentation, this is going to be more of a, I guess you could say, plumbing exercise, because Mark's showing you all the great stuff that we can do with the data that our gateways can collect from your network. But to actually get that data, we actually have to integrate with the network and collect the data actually and pass the packets and what have you. So I thought it was important to start with, where we came from, how we're used to doing things on-prem, and the kind of control we had there. So way back when, and I'm hoping somebody recognizes these devices, but primarily in the old days, you got your wires connected, you got your PCs, your servers plugged into your switch, and it just worked. Or you'd use your dial-up modem and it just worked. It was very, very easy. And in terms of stuff like visibility and being able to see what's actually going on in the network, I mean, a switch would actually, or a hub would actually mirror all your ports, so you could just collect it that way, or you could just turn on something like ERSpan or RSpan or something like that to uh, collect packets on your switch. So you had, by virtue of control, have the ability to collect all your data, anything you could possibly need. Of course, that changed. Some of these are like CSU, DSU, and then a modem. If you're going into a service provider, then it's more like a modern cloud service provider where you don't really have any visibility. So you had a little bit of both back then. Now, moving forward, we got our virtualization. And with that came products like NSX and Cisco ACI. And those all use the concept of overlays on top of the switches and routers that I mentioned in the previous slide. And that enabled us to get very granular data collection, because we could zero in on individual VMs on the hypervisor, individual ports, and we could do microsegmentation, multi-tenancy, routing domains, all sorts of fun stuff. So we really, with the data center, we've kind of achieved, I mean, there's always more to do, but we've kind of achieved that whole good balance of connectivity, security, segmentation, etc. Although I did mention security, there is one issue that came up before the advent of the microsegmentation, and that was that the network really didn't care about security. It was just kind of an open free-for-all. So that kind of landed where you didn't with like host-based firewalls like the Windows firewall, or proxies like ISA from Microsoft, or hardware firewalls, Checkpoint PICs. And then, of course, now even today, we see like stuff like Carbon Black and other endpoint protection installed on workstations and servers for those unknown threats. So we had all that on-prem, but now we're moving to the cloud, right? So we don't control anything. And the apps teams who handled like Exchange and SharePoint and stuff like that, by the time we were doing the cloud journey with VMs and databases and stuff like that, they're already quite familiar. You're basically giving up all your control when you go to the cloud service provider, you go to Azure, you go to AWS. It doesn't really matter, because it's their network, it's their compute, it's their computers. So you're really at their mercy to try to figure out what's going on. And I know there's some support people in the audience and from the CSPs, and they can tell you the same thing. There's really not a lot of telemetry for the customers relative to what the CSP can give you. And if you're trying to do your own troubleshooting, try to do fast troubleshooting, you're kind of at their mercy. And now we have three major, maybe four if you count OCI, of clouds. And there are so many different services in each clouds, and each of them does networking in a different way. So I'm sure some of you can recognize these icons. Some of them are in Lucidchart and Draw.io and stuff like that, so you may be able to identify them. But if you're not like fully immersed in these clouds, you may or may not know what they are, or there's going to be a learning curve for you and other members of your team. At least, you know, there's still IP addresses here, right? And that's something. Now, this overview, this is some of the services in terms of networking that our service providers provide here. And you know, like I just said, it's all very different. I mean, AWS, Azure have a regional VPC. Google has a global VPC. So you can have a region in Iowa, a region in Singapore, same VPC, they route between, no big deal. Address space is defined differently. They handle static routing, firewall rules. BGP is available in some places, not in others. Some of them have their own transit, like a TGW, and or their own firewall, like the Azure Network Firewall. But they all do support at least the external connectivity. Then finally, at the bottom, we have visibility, but that's another can of worms because, you know, what are they really giving you? Are they giving you the full NetFlow experience? Are they giving you what you need? Do you have to do any kind of aggregation, etc.? And then we get to network architecture. Okay, you know, say you start in AWS, you start in Azure, you have a network architecture. And okay, now it's time to add a second cloud. Maybe you're adding OCI because you need their databases, the Oracle databases. Now you have potentially two competing architectures. And now maybe you need two specialists, maybe you need more specialists. It becomes very costly to either train up or hire, and there's just a lot of inconsistency across the various clouds. And it makes sense because they've all kind of done their own thing. They're all competing and stuff like that, but it doesn't help you out if you're a network engineer or architect trying to make sense of it all and produce a workable architecture that's falling within budget and is operational on day 2. Your help desk can handle it, etc. And now another topic that I run into constantly, and not just this job, when I was doing Azure MSP, I had to do the same kind of thing. It was a big deal. Everybody needs firewall insertion. They want their traffic inspected by their Palo Alto or their checkpoint or whatever. But the trouble is that each vendor has a different way of doing things. AWS, up until very recently, they didn't have any kind of all ports load balancer. Yeah, I mean, really, all they had was you could do like IPsec tunnels, or you could do some very complicated routing with TGW. And then even then, you'd have to do SNAT or something like that to make sure you don't have asymmetric routing. Azure was better, but you still have a zillion route tables, and there's other little caveats with route tables around like private link, stuff like that. So you got to worry about that. And then Google, in their infinite wisdom, right now you could have a multi-NIC VM, but each NIC has to land in its own VPC. So you have this nice global VPC with your Palo Alto, but you can only put one NIC of that Palo Alto in your global VPC. And also within that global VPC, you can't send traffic to the firewall and then to another destination in the same VPC. So there's a lot of there's just a lot of caveats with these firewall insertions that you have to do. And then think about if you actually get to that point. Maybe you did, conquer the multiple architectures. You have AWS and GCP. Now you need to connect them. So are you going to use IPsec? You use the native gateways, you're going to hit, if you're lucky, you might get, maybe 2 gig. 1.25 is our baseline, but you might get a little more. But the point being is that you're really going to hit those performance limitations unless you get a third party, like I'm thinking like an Equinix or a Megaport, Packet Fabric, one of those guys, and then use like a direct connect and an express route or cloud interconnect. So it becomes very costly, very complicated if you're going to actually get any kind of throughput. And even Microsoft, currently they have a express route to fast connect that you can build up in the background. But again, you're going to pay for that, because you're paying for effectively an express route and then 2 fast connects to make it work. Now, point on visibility. This is going back to that topic. This is what it looks like. It's just a black box. So you don't really, do you know what your cloud provider is running under the hood? Not really. And it's not always strictly relevant, but you need to get those flow logs out. So how do you get a flow log out? So you turn on your flow logs, your NSG flow logs, or your VPC flow logs. And okay, they're in, like in Google, for example, they go into a cloud logging view within your project. So, okay, now you have multiple projects. You have your host project, you have your service projects, you have a big organizational structure as they recommend. And it makes sense, of course, from the admin and billing perspective. So now what do? You have 10 different logging views, maybe more, and you're trying to troubleshoot an issue. You're trying to detect threats. You're trying to do any of that stuff. So what does Google have you do? They have you export those to BigQuery, which is one of their big data products. And then something like Data Studio would be used for visualization. That, or you buy Splunk, you buy some other expensive SEIM to do the work for you. But especially with the cloud native solution, I mean, I come from a network engineering background, way back when. I've been in cloud for a while, but we didn't really do databases. I mean, yeah, I could install SQL Server, maybe get a connection, but I'm not, I was never a DBA, and I imagine a lot of network people aren't either. It just seems it seems like a lot of work to become a DBA as part of your network engineering tool set. And now also use the transit like TGW and VWAN, and they don't really log either. You're very limited to these VPC logs, and hopefully you get what you need out of them, or maybe you don't solve the problem without calling the Azure support or whatever. And this is a Google record here. So this is a record. So if you're trying to troubleshoot, I mean, I like reading JSON. I'm kind of a big nerd, but at the same time, if the boss is breathing down my neck to solve a problem, maybe this isn't so great to actually see what's going on. Mark showed like the app IQ, and I personally would find that a lot better if I was working at the NOC and I had to actually troubleshoot something. It would point it out for me instead of me having to look at 10 different records here like this. So now Rod did a great job talking about our product in the beginning, so I'm not going to spend a lot of time here. But just to reiterate, we have the controller, which is doing the actual control plane. So it's a separate control plane data plane. So you got your controller sitting here with Copilot, which is what Mark demonstrated. And then you have your Aviatrix gateways that are sitting in your VPCs, your VNets, your VCNs. And this is what is used to actually set up your connectivity and provide all those juicy details that are in Copilot. Now, further down, we do support Terraform. We're a full Terraform provider, so you can use us to deploy your VPCs, your VNets, your firewalls, most constructs within your the baseline of your network. Now, if you're going to deploy an F5 or something like that, we're not going to deploy that for you, but of course we integrate with that. Then additionally, we can export logs to Datadog, we can export to Splunk, wherever you really need, because we're just going to push syslog, we're going to push NetFlow, all these things just to provide the information that you need. And then it's up to you how to manage it if you don't want to use Copilot. So again, here, what I was talking about, transit in the center, and then spoke VPCs, multi-region. And of course, we have two gateways in each VPC, so we do have high availability. Connectivity between all these gateways is encrypted. And we support, of course, the 4 clouds I mentioned: AWS, Azure, GCP, and then Oracle. And in all cases, we can do the high performance encryption either within and between, and we can do firewall insertion. Word about high performance encryption. I just mentioned a few minutes ago that a typical IPsec tunnel in the cloud is limited to about 1.25 gigabits. And that's, of course, because it's all running in software. It's not like it's your Cisco or Juniper on-prem where you have an ASIC that does IPsec encryption for you. It can just blast it out at 10 gig all day. So what we end up doing is we utilize the multi-core situation that all the VM instances have, and we can pin IPsec processes to each core. And that enables us to deliver very high bandwidth between our gateways as aggregate. So you have a 16 VM gateway, and that's 16 times 1.25. You're looking at 20 gig right there just with a 16 core, and we can go up from there. Additionally, this can go to on-prem. We have a appliance called CloudN, which runs our software. And that means that you can deliver this high performance encryption from a transit over a direct connect or a cloud interconnect or what have you, and achieve that same kind of performance. Another useful detail, if you're using, for example, like vWAN or TGW, they do support segmentation, but it's not across clouds certainly, and it's not nearly as easy as this. So in this scenario, what we do is we have each of these spokes is labeled with a segment. And then you can define in policy in the controller what particular segments are allowed to talk to each other. And I'll have an example of it later, but a quick example would be you have like, say you have prod and dev, and then you have a shared services spoke. You may want prod and dev to be able to talk to shared services, but maybe prod doesn't need to talk to dev. Or maybe dev can't talk to on-prem because we can segment there as well. This is just a quick, what Mark was showing us. We have the full net flow from each of our gateways. So anytime a packet hits a Aviatrix gateway, we can actually see it in Copilot. So that's how we deliver the rich visibility, the threat prevention, the app IQ, things like that. Threat IQ, again, we can use that information to lock things down with ThreatGuard. All right, and finally, these are some of the designs I've worked on with customers. This is an example of, this is a pretty full example. This is an example of our segmentation, as well as our on-prem connectivity with CloudN and the SD-WAN. Across the top here, green, of course, is prod. QA is this baby blue color, UAT, dev, and shared services. So like I mentioned before, we could say that these two prods can talk to each other. Maybe QA and UAT can talk to each other for whatever reason, and they all can talk to shared services. And this is all facilitated by this transit. Now, additionally, let's say there's workloads in prod 1 and prod 2 that need to talk to each other. We can actually send this traffic because the spoke will connect to the transit. We can actually do a firewall on a stick methodology, just hairpin the traffic to a Palo Alto or a checkpoint or whatever. It'll come back to the transit, then go to prod 2. Or we can do that really for anything, even from the SD-WAN. Say we have the SD-WANs out here. We want everyone talking to prod 1 to go through the firewall. We can hairpin the traffic from SD-WAN via the transit and then send it up to prod 1. We natively support BGP to talk to these to the SD-WAN appliances, so we don't lose any speed by doing IPsec tunnels there. And then the CloudN I mentioned. In this scenario, we have a VLAN attachment going to the edge router, and then the CloudN builds the overlay, just like the high performance encryption, same technology, and it talks to the transit. And then if we had transit, the same kind of architecture in a different region for DR or for whatever other reason, we can peer with that transit with high performance encryption and have full connectivity. And even then, let's go from the CloudN to an imaginary undrawn spoke over on this other transit. You don't even need another direct connect or interconnect or anything. We can transit that entirely over our Aviatrix transit. Of course, we have the dual environment. So quick little diagram here that shows that we have GKE over here in the Google Cloud Platform, and we can talk to a workload VM over here in AWS, again, over high performance encryption, Or alternatively, if you want to route it via your cloud interconnect and direct connect through your colo or data center, we can do that as well. Now, one interesting thing about the way Google does load balancers, they don't have anything like an ALB or an app gateway. Their load balancers are all fabric level, so there's no VM instances behind the scenes like an app gateway sitting in your VPC. So to actually do any kind of firewall inspection, you have to land the load balancer on something that isn't your GKE cluster. So in this case, we're landing them on Nginx to proxy it to the GKE cluster. And like in the previous examples, we can hairpin this to the firewalls before it goes to the GKE cluster. This workload here, we had one customer who had a lot of shadow IT. And I don't know if that's a bad word. Somebody told me it was a bad word within the corporate community. I'm not sure. But in any case, we had a whole bunch of departments at this company that were just running the credit cards, spitting things up in Azure. And they're all overlapping CIDRs. They really had no coordination, no IPAM, no security governance, nothing like that. So eventually this company signed a big deal with GCP, and they decided everything needed to be reined in, put under the GCP umbrella. So we were able to help them do that. The way that worked is we stood up their GCP environment with our transit and the spokes just for their new workloads, their greenfield. And then we're able to connect the Azure VNets with our spoke gateways directly to the GCP transit. Further, we were able to NAT all their workload segments that were in the overlapping IPs to facilitate migration. So they're still in progress, but once this is all done, we can basically decommission the Aviatrix spokes and their Azure environment, and they're all done. Of course, they're probably going to stay in Azure. I mean, no one ever leaves a cloud. No way. All right. That's all I got. Thanks everybody for listening. I don't know if there's any questions. Rod, were there any questions for me?
I was just answering one. Aaron asked about dynamic route via hairpinning, probably looking at your the diagram there, and I was responding that we can actually support BGP path prepending to route normally over whatever your primary route would be. Let's say that would be going over an high-speed Equinix connection, but then we could route a secondary route maybe across the internet and still maintain connectivity to wherever that primary route was connecting to if it goes down.
Okay.
But I don't know if that was what Aaron's point was.
Were you asking about in this FireNet scenario here where we're hairpinning the traffic to the firewalls?
This is Aaron, so he would have to respond there. I don't know.
Oh, that's right. Yeah, they can't talk. Let's see if he replies in chat. But I'll try to answer if that's the case. What we do is we integrate with the firewalls with the APIs. So we initially plumb the RFC 1918 ranges. And if there's any public IPs that are in the BGP advertisements coming from your on-prem or from anywhere else, we'll write those into the route table as well. So that way it gets sent and then it comes back based on that routing.
Yeah. Okay.
I didn't see anything else here.
All right. Yeah. So if you do have questions for Matt and the team, I'm assuming Matt, you're the last.
Yeah, I'm the last presenter right now.
All right. Yeah. So if you have questions, there is the general chat that's open. There's also a Q&A chat. I didn't see any questions in the Q&A section. But definitely, on cloud networking, if you've ever dabbled in cloud at all, because we have a mix of attendees may have done a little bit of cloud, maybe a lot of cloud, but all the learn to get certified networking examples are all very simple. The certification specialties, they definitely get harder, but just that your basic cloud networking makes everything look nice. It's nice and easy. It's going to work. But with what you guys have shown, if you're going to do anything somewhat complicated, that's where all the fun comes in. And can you talk about, we did see on the demo and other things that it gives a nice view of everything that's there, whether you're in one cloud, multiple clouds, or on-prem. Could you give people an idea of, if they didn't have something like Aviatrix, what would they be doing to try and troubleshoot an issue? What tools would they be using besides this?
Yeah, Jim, I can answer that. I mean, just to give you an example in AWS, for instance, that one screen that Mark showed called App IQ, which basically showed a map between two devices, and then it showed all of the different pieces in that. That one report would take 13 different windows to be opened in AWS to be able to look in their console at all the different things, and it wouldn't highlight all of the specifics. It would basically there'd be a lot of human correlation that you would look at these different windows and try to figure out what was all there. And so that's something we hear from our customers a lot, that they really like the visibility that we can deliver here, that they find is missing from any of the cloud providers, honestly. And I just wanted to add a point to your point about education and kind of learning about these things. We actually have something called ACE, which is Aviatrix Certified Engineer, and the associate class, which is the first level and prerequisite to go into the pro level and stuff, isn't really about Aviatrix. It's actually about how networking really gets done in each one of the clouds, and then a little bit at the end about Aviatrix and pulling that all together.
Okay.
So if anybody's interested in that, get in touch with Corbin, and we can get you a code for, free class and certification. It's about a 4-5 hour self-paced online thing. And it's, I think, really worth it. We've got about, I think, close to 17,000 people who have been through that now.
I deliver the GCP section, so if you like listening to me, that's something to look forward to.
All right. Yeah. And Corbin, can you email those to me as well? I know they're in the chat. And I'll make sure on the event wrap-up page. So if you're someplace, if you're listening to us and driving, and you're like, dang, I can't see that link in the chat, I'll send me the links, Corbin. I'll put them on the event page. And then when the event wraps up, you'll be able to come to the same page that we're on now, and it'll have the event video and the additional links that we have for additional learning. No, it's great to hear those, and that's so those fundamental skills. Even if you're in app dev or in some other non-networking part, just from my personal opinion, adding some of that fundamental network stack and knowledge, I think can help kind of power other parts. If you understand the network, you can help understand how to make applications work better, how to make how to secure things better. Do you guys, besides the basics, if somebody wants to get even deeper, do you have?
Oh yeah. Yeah, we have a whole bunch. We have, I don't even know the names of them all, but we have professional, we have ops, so specifically designed for people who have to deal with ops. We have a DevOps one that's infrastructure as code, how to leverage Terraform and use the repo that we have to get some of the things to get you started in that. And we have a couple more. In fact, we have customers like Nike who have built this into their curriculum for anybody who is working in their IT department. They can move up by taking these different classes, and they actually using our content there.
Okay, no, that's good information, and we'll have these specific pages, and if you have anything, I'm assuming the Teachable, Aviatrix.teachable has people can find
Yeah, and some of it is
everything right there.
online there with Teachable, and some of this is like, for instance, our professional level and our design level is
Yep.
actually instructor led. So
Oh,
it's
okay.
a 3-day, and we have instructors that go through the whole thing, and there's labs associated with it. It's really fantastic on hand.
Okay. No, that's great. We didn't get a lot into the technology of Aviatrix, but are there any, everybody's, talks about, open source technology. I know, I'm assuming a bunch of the components here are, highly specialized, but are there any of the components that you guys have open source that if somebody's working at a company and just wants to try it out, or maybe not even working on a company, but has their own consulting company, they can just grab something from Aviatrix and kick the tires?
So we don't have open source, but there's a couple of different things that they can do. We have something we call Build, which is about an hour and a half where you get your hands on and actually try it, and you build it in one of our labs. We also have Flight School, we call it, which is more like a 6-hour commitment, but you build multiple labs and so forth. We also have, if you want to build it in your environment, we have something called Sandbox Starter, which is really just an automation to build it out for you. And that ends up costing you, because you're building it in your own accounts, it ends up costing about $1 an hour or something like that. So $25 a day, you can actually build out a multi-cloud network, try a lot of these use cases, and then tear it completely down and rebuild it. So it's all available out of the workplace or the marketplaces. So you can basically download it, try it, pay for it on a metered basis, and tear it down if you don't like it.
Okay, no, that's great to hear. So sometimes I like to ask our presenters some some non-technology questions, and I think we'll unless questions come in on the Q&A, we'll maybe end up with this kind of career advice type question. So if you if you could go back in time, and you can't say buy Apple stock, okay, don't do that one. You can. It's always a funny one. But if you could go back in time and tell your younger self some career advice, what would you guys say? And you guys can take turns. Rod, did you want to start since your mic is on already?
Yeah, sure. I mean, one of the things, and I'm gonna not say this from my point of view, because I'm sort of from the vendor point of view, and I feel like I made the right decisions. But we hear this a lot from customers, and we see it a lot, that the people who get what we're doing the most are networking guys, right? They were CCIEs, they built out the network on-prem and so forth. But a few years ago, they saw that the on-prem data center was at least getting smaller, if not going to go completely away. And so they moved to the cloud teams and started really understanding what was going on in the cloud. And those guys understand what we're doing the best because they left with the knowledge of networking, went into the clouds and found, hey, there's a lot of stuff missing here. This is really tough, and we can't do what we used to do on-prem. So then when they see Aviatrix, they really understand that. So I think going back in time and moving into, cloud a little bit faster, understanding cloud. I mean, I've been talking about cloud for 10 years, but really big enterprises started moving into the cloud for real about 2 years ago, right? Everything else was sort of playing around before that. So I think that would be probably something I would suggest people had done earlier in their career, was kind of get involved in cloud.
Well, it's funny you say that, Rod, because that's exactly what I did. I mean, back in like I'd say 2015, was it 2015? Yeah, something like 2015, 2016. I was working at a credit union. I was their network engineer, firewall engineer. And the cloud had just kind of really started to pick up. and we were an Azure shop. So I was doing Express Route, I was doing the VPNs to Azure, stuff like that. And it's kind of like, I was thinking about it. It's like, yeah, this is probably the way it's going to go, because I'd seen my previous like Exchange deployments all moved to Office 365, stuff like that. So it felt like the writing was on the wall. So at that point, that's when I actually went to Microsoft and spent a few years there picking up Azure networking, and then moving on to an MSP to do more Azure deployments and engineering and architecture, stuff like that. So yeah, I definitely agree with that. That, you know, looking back in time, yeah, getting into the cloud, getting especially on the vendor side, is probably the way to go, because I mean, the more experience you get, I think it just helps you out, because, and if you're on the vendor side, you're going to see a zillion different customers, a zillion different viewpoints, zillion different deployments, and that's just, you're just going to learn that much more. It's like drinking from that proverbial fire hose.
And I'll add one other thing that we see a lot, Jim, that people should concern themselves with. Number one, the decision to be in a particular cloud or multi-cloud is actually not a decision made by IT these days.
Yep.
It's a decision made by the business. And we've seen many times where an IT team has said, nope, we're going to be in Google, or we're going to be in AWS. And that's the strategic decision that we've made. And then we say, okay, you know, they might be using Aviatrix because they like the added features that we add. But then we get a call 60 days later that says, oh, hey, we now got to move into Google. And this was exactly, we've seen this for a couple of different reasons. One, customer driven. They say, you know, over our dead body, are you putting all this in AWS? You need to be in Google, or we're not going to be using you. And the other is acquisitions. Companies are acquiring other companies, and they find that, hey, this technology they just acquired is running in a different cloud than their primary cloud.
Yep.
And IT needs to respond to the business quickly. So building an architecture that will allow them to respond to the business quickly is something I think, if you were forward looking, you would want to be thinking about.
Well, thanks for that. Thanks for that, Rod. And Corbin,
Yes,
do you have
sir.
any thoughts on what you would do, what you would tell your younger self, some career advice?
Yeah, that's an interesting question for me, as I've took a unique path to the technology world.
Sure.
You know, before I got involved in tech, and you know, my background is you know, I was at Four Scout to start my career. Then after that, I made a journey to Okta, and then I was you know, very thankfully recruited over to Aviatrix. But before all of that, I was, you know, running into people with a football helmet trying to make a career. So I wish that I would have studied technology earlier in my schooling days. Right. I think that it would have been beneficial to learn to make cool investments like Apple back in the day. Like knowing that, you know, knowing the cool tech out there and the business value that it's driving across all these organizations, when you have, you know, cutting edge technology that's really game changing. You know, that is something I wish my younger self could have done. Right, studying tech in either college or earlier years, and having a better grasp of what I was getting into. I think I could have accelerated my journey even faster.
All right. No, thanks for that. So I'm not seeing any other questions. So Matt, can you unshare your screen? I'll share kind of a wait screen. Let me just get it all set up here. And what we'll do, we'll move on to this next the next section here, where we'll and I've lost my share button.
Oh, I have a share button, but you
Yep.
should have it too,
No,
right?
and, it was there. It was covered by Windows.
Okay.
But definitely thanks, thanks Matt, thanks Rod, Mark, Corbin for organizing everybody. You know, give a round of applause. You know, the golf clap round of applause. Don't want to blow at the everybody's speakers with a loud clap. But thank you. Really appreciate you guys coming out and spending time with us.
Well, thanks for
Sure.
the opportunity.
Yeah, thanks for having us.
I truly appreciate it.